Hey, in this video we'll be talking about some of the simple interactive features that are included with SDL. And you could really take these features and make a complete game out of them. So some pretty useful stuff. We left off with drawing just a simple image on the screen, and I can move it around with the arrow keys. And part of the code we used was in draw to screen. This is where we kind of took all of this information about the texture and where we wanted to draw it, X and Y, and we used SDL render copy in order to put it onto the screen. So I'm gonna copy this function, and I'm gonna make a duplicate of it just to work in for now, because there's another function very similar, SDL render copy EX. So it's an extended version, an extension of this function, and it has a lot more parameters, as you can see. It takes a renderer, takes the texture, takes the source rectangle, that's what we got there as null, destination rectangle, we've got that. It also takes an angle, so it does rotation. It has a constant pointer to an SDL point, that's the center of the rotation, and then a renderer flip argument. So let me try to fill the rest of these out. Angle, center, flip. So for an angle, let's try just like 45 degrees. For the center, if we put null pointer, that will treat it as the center of the image, so it'll be half of the width, half of the height. And then for the SDL renderer flip, we can use a special flag that SDL provides, SDL underscore flip, and then choose one of these. This is going to just control the mirroring of the image. If you wanted to flip it upside down or side to side, like if you were a character that just turns back and forth left and right, you could flip it that way. I'm going to flip it with none, so no flipping at all. And try running that. So we see it rotated 45 degrees, and it is rotated about the center of the image. So let me try changing that part of it. This was the center, null pointer, and the type is supposed to be a pointer, so null pointer is valid, but it's a pointer to an SDL point. So let me make a temporary SDL point here. We'll just call it center. And I'm going to initialize it. An SDL point has just an X and a Y component. It's just a two-dimensional point. If I do something like width divided by 2 and height divided by 2, this should do the same thing as null pointer. I want to pass in center, but I actually want to pass in the pointer to center, so the address of center. Alright, looks the same, but to be certain, I'm going to change the angle that I'm rotating at. 45 is just one angle. I kind of want to make sure that this is correct, that is rotating about the center. So I'm going to try to make it change over time. Let's do, let's see, we saw SDL get ticks tells us something about the time that's passing. So let's do divide by 1,000 to make that a number of seconds that's passed since the beginning of the game. And then if I want it to be like 90 degrees per second, 90 times the number of seconds that have passed, then that should work. Let's try that out. Okay, so every 1 second it's turning another 90 degrees, and it is definitely rotating about the center of the image. Cool. So if I wanted to change the rotation point, this pivot point, I could go like 0, 0, which is one of the corners of the image. So you can see how that looks. There we go. So this is the upper left-hand corner of the image, 0, 0. So SDL uses an inverted y coordinate system where positive x is to the right and positive y is downward. It's just an old convention for computer graphics. So anyway, if I just want to rotate about the center, about the center point of the image, then I can just use null. Okay. And I'd also, I don't really want all of the sprites in my game to just be rotating constantly. I'd like to have more control over this instead of just leaving it up to time passing. So I would like to do something called parameterizing this. I want to turn this into a variable because that's the only way I'm going to be able to control it if it's a variable. So I'm going to say, call it degrees, and I will make this function a little different so that I pass in the amount of degrees. And now we have two compatible versions of this function, draw to screen. One of them works without an angle, and one of them works with an angle. So if you provide this extra information, it'll call this second function. So this is an overloaded version. Okay, that looks fine. So now where I have my smile.draw, this is the sprites draw function. Let me go to that definition. Draw is calling draw to screen with an x and a y. I'd like it to call with an angle as well. So let me put another float in here. And I like to call my angles degrees if they are in degrees and radians if they're in radians, because if you just call it angle, then it's really hard to tell which measurement system you're using. So I'm using degrees specifically. Okay, so degrees, let me initialize degrees. I think 0 is a good default value for that. And so now I can change this degrees variable, and it'll automatically make my image draw at that angle. So if I did something like smile.degrees plus equals 1, right? This is a bad idea if you remember from last time. This will be once per frame when I might want time dependence involved. So I want to multiply it by a delta time in order to better control it. Times dt. So this will be 1 degree per second now instead of per frame, which is a very slow rotation. Okay, but I also don't want it to just rotate a bunch every second. I'd rather have direct control of this. So give the user some way to rotate this character. So if I look above using key states, I could do this. If key states, let's say, use the A and D keys. So if you press A, if you hold A, then let's rotate. And if you hold D, let's rotate the other way. And let's see if I got these the right direction. Alright, so A and D, yeah, it looks backwards. So minus, plus, there we are. Cool, so now I can move and I can rotate. That's good. If I pump this up, this would be more like, maybe more like a game like Asteroids or something, where you could move around the screen and point and shoot in that direction and stuff. Okay, so this is one way to control things using the key states, but there's another way that I showed up above using key events. So when you are holding down a key, you can detect that with key states. What is the state, the current state of this key? Is it pressed or is it released? If you want to respond to isolated events, you have to use the event system. So this is checking to see if the event is a key down event. And notice that all of this processing of the events happens within this while loop. And we can check if this is an escape key, then we're done. I might want to do something else with this. Let's say if the key is the enter key. So in SDL it's referred to as the return key, but this is your enter key. If you press the enter key, let's like make the background change color. So let me look down here. SDL set render draw color has RGB and A, and I could specify background red, background green, background blue, and then I can make these variables. So I'm using uint8 because this this data type is an unsigned 8-bit integer, so it goes from 0 to 255. Those are the possible values for these color channels. So it's an appropriate data type. So red, green, and blue. I don't remember what blue was supposed to be. And then when we press enter, we could change them. So let's do something like I don't know, some cheap random value for each of these. There we go. Cool. So now every time I press enter, new color. It also has the effect if I press and hold the button, there's a delay and then there's a repeat. This is kind of something that you might be used to when you're typing in like a word processor, but it's not something I want in my game. So I'm going to say if the key is SDLK return and there's this other property I can check, repeat. So if it is a repeat, this will be true. So I want it to be not a repeat. There we go. So if it's the return key and it's not a repeat key, then switch the colors. So now I can press it, but if I hold it down, nothing happens. Okay, looks great. So with just these features, you can make all sorts of different games. Lots of retro classic 2D games, arcade games, and even some newer styled games can be done just with really simple tools. So I hope you try something out, try using this and make a great little project to show off. See you later.